Okay, so hi everyone. In this video, we are going to discuss about the readers and writers problem. In the previous video, I have discussed the producer-consumer problem or the bounded buffer problem. So if you haven't watched that video yet, so kindly visit that before watching this video. Okay, so the readers-writers problem is another one of the classical problems in synchronization. So in this problem, there are multiple readers and writers that access a shared database. And what the readers do is to simply read data from the database, but the writers can both read from and write to the database. Okay, so the problem is to ensure that the readers do not interfere with each other. So both of them all of the readers can simultaneously read without interfering to each other's reading process, and that the writers do not interfere with the readers or with the other writers. Okay, so again, there will be a set of shared data objects or a shared database, simply said. And there will be a group of processes, the readers and the writers processes, wherein the readers will only read the data and the writers will only update the shared objects. So a writer process has an exclusive access to a shared object. So in other words, the writers will be given a priority. And there are several problems here. The first problem is on the writer side, and the second problem is on the reader's side. So not solving this readers and writers problem may result in starvation. So these are the problems that we must consider. So on the writer side, there only one writer is allowed to write at a time. So we mentioned that no other writers can interfere with a writer that is already writing. And at the time of a writing, then the reading is not allowed. So when the writer has already started writing, then the readers will have to wait until the writer is done writing. Okay. And for the reader side, this is the problem that we have to consider. So we should allow multiple readers to read simultaneously. And once there is a reader that is reading, or if there are multiple readers that are reading, then the writing is not allowed. So if the writer wants to write something, then they have to wait for all the readers to complete reading. Okay, so here is the general code for the readers. Okay, so we have a semaphore mutex, and we have the wait and the signal operations as well. So what this means is that we have a mutex na semaphore that indicates whether the reader can already read. Okay, so it tries to acquire that shared na database because it wants to read. So it must see if there is a writer that is writing. Okay, so initially the mutex is equal to 1. And the problem here is that if there are multiple readers, so let's say initially we have one reader, right? And then another reader and another reader. So what happens to our mutex variable is it becomes negative. Okay, so essentially this reader has already acquired or has already got a lock on the mutex and it started reading. Okay, and because it has become negative, these other readers must wait for their turn in order to read. Okay, and we don't want that. And as we mentioned in the problem, we should allow multiple readers to be able to read simultaneously. So we can further modify the code and we can allow the multiple readers to read simultaneously. So our solution would be that if the first reader has already tried to read, then it will call the mutex. okay, or acquire the lock. And this reader will not be the one to release the or to release the lock. Okay, so if another reader wants to read, then yeah, continue lang siya until such time that the last reader has stopped reading. So the last reader will be the one to release the mutex or release the lock. So you will understand that later with the simulation. Okay, so this is the modified the codes for the writer and the reader. So for the writer side, we have the WRT na semaphore or write semaphore. And for the reader side, we have the read count na semaphore. Okay, so essentially the read count na variable or semaphore keeps track of how many processes are currently reading the shared na database or the object, while the write semaphore, which is initially has a value of 1, functions as a mutual exclusion semaphore for the writers. So it is also used by the first or the last na reader that enters or exits the critical section. It is not used by the readers who enter or exit while other processes are in their critical section. So let us try to understand what it means. Let's starting from the reader. Okay, so we have the read count variable. So if we have another na reader that wants to read, then we add the read count. So it keeps track of how many processes are reading. So if read count is equal to 1, it means that there is one reader that is reading, then we get hold of the WR write na semaphore. The write semaphore must wait. Okay, so it signals, kumbaga, that the writer cannot write at this moment since there is a reader that is reading. And then the reading is now performed. And if the reader wants to stop reading, then it decrements the read count na variable. And if there are no more readers that are reading, then it signals the write na semaphore, essentially adding 1 to the WRT, meaning the or releasing this write na semaphore, meaning the writer can now write. Okay, so the problem here is that the read count na variable may be simultaneously modified by different na readers. Okay, so it could be a problem. It could be a problem. So one solution here is to add another semaphore, which is mutex. So if a reader wants to read, and in order to modify the read count na variable, it acquires the mutex. So it means that a lock is acquired and no other readers can perform changes into the read count while it has not completed modifying the read count na variable. Okay, so let us discuss it more deeply. So this is the whole code. So we have for the writer na process. Okay, so we have a do while loop that will run while this is true. And if the writer requests for a critical na section or wants to perform writing on the shared na database, then it must check if the write na semaphore is available. Okay, so wait operation on the write semaphore. So if the write semaphore is not being held or used by any other na processes, then the writer will get access to it. So if it is successful, then any other readers or writers won't be able to read or write anything on the database because the write semaphore is being shared by the readers and writers. And we have also mentioned in our rule that once a writer starts writing, then no other readers or no other readers can read on the database and no other writers can write on the database as well. Okay, so once it is done writing, then it signals that it releases the write na semaphore. Now, for the reader na process, so it performs wait on the mutex semaphore. So it essentially acquires a lock when the read count variable is being updated. So as we have shown earlier, this is done so that multiple readers cannot simultaneously modify the read count ng variable. Okay, and we have the read count variable to increment to indicate that another reader has started or wants to read. So now if the read count is equal to 1, that means that we have at least one reader. It means that at least one reader is trying to read from the database. So if there is a reader, then we should not allow the writer to modify the database until the reader completes reading. Okay, and now it signals the mutex, releasing the lock, meaning it is done modifying the read count of variable, and that reader can now read. Now, it acquires the mutex since it wants to modify the read count variable again. So this is the part wherein the reader is already done, a certain reader is done reading, so it acquires the mutex, and it decrements the read count of variable. And at this point, if the read count is equal to 0, so if no more reader is reading, then the writer can enter its critical section. So it releases the write semaphore, and the writer can now write. Okay, so if a writer is in the critical section and n readers are waiting, then one reader is queued on WRT or on the write semaphore, and the n-1 readers are queuing on the mutex na semaphore. So when a writer executes the signal, this one, signal write, then we may assume that the execution of the waiting writers or a single reader. So that means that another writer may start writing or another reader may start reading. So whether the next na task will be of the reader or the writer, that depends on the selection made by the scheduler. Okay, so let us try to have a simulation. So this is the source code for the writer, and this is for the reader. And we have 3 semaphores here, the read count, the write, and then the mutex, which are initialized with a value of 0, 1, and then 1. Now, the first process, assuming reader 1 wants to read. So it checks if there is mutex is less than 0. Okay. Now, it tries to acquire the mutex, acquires a lock on the mutex since it wants to modify the read count of variable. Okay, so we can see here that the read count is greater than 1. Okay, and if the read count is equal to 1, then it must wait on the write na semaphore. Okay, and that means that we are trying to put it on queue, kumbaga. So it signals the write that, okay, I want to read, so please keep hold, ganon. So we can see that the write na semaphore is also decremented. And now it signals the mutex again, or releases the lock on the mutex. And it starts reading. Now, assuming that the reader 2 wants to read, okay, and we can see that the read count na variable is also added with 1. Okay, and if read count is equal to 1, and of course we must wait on the write semaphore, perform wait on the write semaphore, but this results into false because reader 1 has already informed the writer that it wants to read, and in this case the read count is equal to 2, indicating the second na reader. So we just skip this, and it performs signal on the mutex again, and indicating that it is done modifying the read count ng variable, and read 2 may now start reading. And after that, the reader one wants to stop reading. So it decrements the read count, no variable. So you can see the read count is now 1. And if the read count is equal to 0, then we release the write na semaphore or send a signal to the write semaphore, signaling the write that it can now write. However, reader 2 is still reading and read count is equal to 1, as you can see here. So the writer cannot enter its critical section yet. Okay, and signals the mutex since it's done modifying the read count variable. Now, assuming that the writer wants to write, but here it is false since the reader 2 is still reading, so the writer cannot enter yet, and a signal to the write semaphore was not sent yet. Okay, and assuming that the reader 2 wants to stop reading, so the read count of variable is decremented, and there are no more readers left, and this now results or evaluates into true, and we are now releasing the write semaphore, and the writer can now write. Okay, and the writer stops writing, assuming. So we are back to the original na initialize the mga values. Okay, so in the next video, we are going to discuss about Chinese philosopher's problem and how we can solve it using monitors.